plug in a number. What else when I plug in a number?
Okay, plug in -2.
You gotta be really loud.
Okay, plug in -2. I got undefined.
Undefined. So you plugged in -2. Oh, it's flinching or which is it weird here? Ah. Hopefully it hangs in there. Correct? That's what you did there. Now I'm going to disagree with your answer. Apparently there's some movie I'm about to quote. If you have an undefined limit, that means you don't know where the limit is, correct? That means you have no limit. Therefore, the correct sentence, the correct answer to this problem is the limit does not exist. The limit does not exist. Okay? You can't write doesn't exist. You can't say anything else other than the limit does not exist. Welcome to calculus. The words matter. The limit does not, oh man, exist. Oh no, he's got seizure problems. Every day it's something different. All right. So what happened there? Because I saw some swirly faces over this side, although I can only see the top part of your face, so I'm probably wrong. Miss Jenkins, does that make sense? If your limit's undefined, really what you're doing is you're approaching infinity, right? As you pick numbers closer and closer to -2, you're going to get the bottom get closer and closer to 0, which means the top you're dividing by 0, which means it's a really big number, right? So if it's a really big number, that means there's no limit. I can't be stopped by a limit at infinity or beyond, right? So therefore, the limit can't exist. There is no limit, is what we'd say in normal parlance. Does that make sense? Okay. So we end up with undefined, the limit does not exist. All right, we try the next one? Wow, this is really going to bother me. All right, that's all. Calculate one student that you are. It's nearly your next. Yeah.
All right, I got. Wait. 0.
0 on the top.
And then it's all 2 on the bottom.
2 on the bottom. What is 0 divided by 2? 0. So the limit's 0. That one will fool you something because you freak out because I got a 0, but it's not. It's just 0.
Right? I did it, and then I was looking at it, and I was like, wait, what does that mean?
Means this thing is, as this function approaches 0 from the left and right, it's approaching the value 0 for y. All right, with that in mind and knowing how easy this is so far, you flip this over. You got 1 through 14 to do. Go. Is. So here's the dealio. Plug in a 3, you're going to get square root of 0. Square root of 0 is 0. That feels like it's the limit. It's not. How's the limit different from doing the problem? Keatska, what's my definition of a limit? I see your fingers moving together, so approaching it from the left and right, correct? Okay, let's sketch a graph of this function we very casually wrote 0 down for. That's a square root. Minus 3 means I shifted 3 to the right. 1, 2, 3. It would look like this. Agreed? So as I approach 3 from the right, I am indeed approaching what number? 0. As I approach from the left, how do I approach from the left? There's nothing there. Can I approach from the left and follow the function? So since I can't approach from the left and right, the only correct answer is the limit does not exist. So limits are different than just plugging in numbers. And sometimes you have to keep that spidey sense in the back of your head, like, wait a second, this might be something weird. If it's something weird, it's not a normal smooth function, then you might have to deal with this. That make sense? All right, here we get assignment 1-4. Online check, any questions? First question. Okay, so this first problem on number 1-4. Try it out. We have to fill out the table because 0 of 0 doesn't tell us where the limit is. And it turns out this thing actually has a limit. solvable. The reason is because we know from Algebra 2 how to deal with this. Let's graph it. Limit as x approaches 3 of x squared minus 9 over x plus 3. Minus 3. In Algebra 3 class, they taught you a long time ago how to simplify that fractional algebraic expression. How would you simplify that? I'm going to make more to it. More. How do you simplify fractions? You factor top and bottom. Bottom can't be factored. The top can be. How do you factor the top? Be really loud because they got to hear you. Go ahead.
Factor into x minus 3 squared.
It is an x minus 3 squared. It's difference of perfect squares. There you go. Anything cancel out? Yeah. And if I plug in a 3, what do I get? That's it. Why does that happen? Here's why it happens. If you think about this, this is true for this expression. So it would graph like this. And so at 3, I would in fact have a 6. But what's wrong with this graph is this. You're ignoring the fact that we had an x minus 3 to begin with. Can I plug in a 3? What do I get when I plug in a 3, sir? Undefined. So at that one spot, at exactly 3, we have a hole. Now, we are approaching 3. There's no 3 there. Oh, sorry, we're approaching 6, right? But there's no 6 there. The limit exists at 6, because that's what we're approaching. But at the spot, we got undefined. That's why we can't graph it. That's why we couldn't do the math for it early. Right? Jenkins making sense? Okay. So the limit would be 6 in this case. So if you end up with 0 over 0 when you first plug in the numbers, the second rule for taking limits is this. Factor top and bottom, cancel out a common factor, move on. Okay? Laura and Moore, make sense? Okay, so if you get 0 over 0, that means a limit could exist. So what you're going to have to do is you're going to have to figure out what it is by factoring top and bottom and canceling out the common factor. Good?
Yes.
Yeah. Good? All right. Now that you're all good, go ahead and start the next, go ahead and hit the problem near the bottom. Starting with 45 and 46.
Oh no, it was too far.